Chapter 2, Exercise 16. Hints. Use Theorem 230 to show that the set E and its complement, E complement, equaling this, are open in Q. Then use Theorem 223 to show that E is closed in Q. Finally, use Theorem 233 and Theorem 234 to show that E is not compact. Solution. Let P be a point in Q. The inequalities p squared greater than 2 less than 3 hold if and only if p in between these or p in between these. Thus, we can express E as E equaling this. Since the set here is open in R, being a union of two open intervals, Theorem 230 implies that E is open in Q. Next, consider the complement of E in Q, E complement equaling this. Since plus minus square root 2 and plus minus square root 3 are irrational, see example 1.1, we have E complement equaling this. Since this set is in the intersection of Q with the union of three open intervals in R, it follows from Theorem 230 that E complement is open in Q. By Theorem 223, this implies that E is closed in Q. Now we check whether E is compact. The set E is bounded because for any p in E, we have absolute value p less than square root 3. We now show that E is not compact. By Theorem 233, if E were compact in Q, it would also be compact in R. Hence, it suffices to prove that E is not compact in R. For any delta in this, there exists a rational number p such that p in between these. See Theorem 120b. Then, p in between these and p squared in between these, so p element of E. Since p does not equal square root 2, it follows that every neighborhood of square root 2 contains a point from E distinct from square root 2, meaning that square root 2 is a limit point of E. However, since square root 2 not in E, the set E is not closed in R. By Theorem 234, this implies that E is not compact in R. Comments. This exercise demonstrates that the Hein-Borel theorem, which states that a set is compact in R if and only if it is closed and bounded, is not a hereditary property. That is, this property does not necessarily hold in subsets of R. However, one can show that Hein-Borel equivalence does hold for closed subsets of R. Of course, Q itself is not closed in R, which explains why E fails to be compact in this setting. Thanks for watching.